Alright, in this video I'm going to talk about Newton's laws of motion. So let's begin with that. The first law says that a body at rest remains at rest and a body at motion will remain in motion with a constant velocity unless it is acted upon by a force, an external force. So what does that actually mean? It says that if you say have a body and it is just lying there, not going anywhere, so there is no net force on it. The net force is actually zero. We say net force and not just force because there are forces acting on it. However, their sum is zero. Like if you say there's a book lying on the table, assume that this is a book. You can say that this thing is our book and is lying on a table. So if this thing is lying on the table, that means it has a weight, so there is a force acting on it. However, the table is also exerting a force on it upwards. Let's call the force to be N. These two forces are opposite to each other and they are same. They have to be same because the book is not moving. So this is what the first law is about. When an object is at rest, you say that the net force on it is zero. The same way, if an object is in motion, you roll a ball and just continue to roll, or maybe in space you throw a ball and just keep on going away. In those cases, you say that the net force acting on the ball or on the object that you have thrown is zero. It is not the force, it is the net force. There may be forces acting on it, but the net force is zero. That's the first law. First law also identifies inertia. Inertia is the property of an object to resist its state of motion. So that means if you have, let's say, 1 gram object and one of the object has a ton of weight, obviously 1 ton object would be more difficult to move, or you can say it would be more difficult to change the state of 1 ton object. So inertia actually is the mass of an object. That's how you define inertia. The more the mass, the lesser the object is going to be willing to change its state of motion. This is what we can say. Same way, a 1 gram object, because the mass is very low, its inertia is very small. If the inertia is very small, you can very easily change the state of motion of this 1 gram object, just because the inertia is very small. It doesn't resist the change in its state of motion as a 1 ton object does. So inertia is mass. That's how you define inertia. The first law also identifies your observer. Everything in physics is revolving about the observer. Whenever you want to find something, whenever you want to find any measurement, do any measurement, you must define your observer. From where are you measuring? Who is measuring? That is what an observer is. In the first law, you say that observer is on an inertial reference frame. We'll talk about this later on, but for now you can just think about this. observer is on an inertial reference frame if the first law has to be applicable. We'll talk about this later, but let's first talk about the second law. The second law states that if an object is acted upon by an external net force, so here you have a net force. Let us call the net force to be F, and this is the net force. There may be several other forces, and we are taking the sum of all those forces, the vector sum of all those forces, and we are combine that into a single force F. Let us say that this object has a mass m. So the second law states that if you have an external force, you've got to have an acceleration. The heavier the mass, the more the inertia, the more it will resist the change. So we should say that, or we should think that the more the mass, the lesser is going to be the acceleration, because the object is going to resist the change in its state of motion. Therefore, F equals ma, or you can say acceleration is the force divided by the inertia. Acceleration is a vector quantity. It has a direction, and in this case the direction is same as the direction of the net external force. So in this case the mass m would be moving towards right. In the direction of the net external force. This is the law that we are going to use mostly when solving problems involving Newton's laws. Let us take an example of this. Let us say you have an object and there are two forces acting on it. Here's a 3 Newton force, here's a 2 Newton force. Now I need to find out what is the acceleration of this block if the mass is given to be 2 kilograms. How to do it? First of all, you find out the net external force. 3 Newton is acting towards right, 2 Newton is acting towards left. So we can say that the net force would be 3 minus 2 newtons towards the right for the 2 kilogram object, or you have a 1 Newton force acting in the right hand side. Now we have the net force. Once we have the net force, we can find out the acceleration. That would be given by 1 divided by 2, or this would be 0.5 meters per second square. Remember, whenever you are finding the acceleration, the force has to be in newtons and the mass has to be in kilograms. Now let's take a look at the final law, which is Newton's third law. Newton's third law says that every action has an equal and opposite reaction. Let us say we are trying to push this object with some force F. Now this is an action. Action is done on an object. Application of the force is our action. But as we apply the force, we are in the contact with the object while applying this force. The object also is going to apply a force on us. So let's call this to be our man. The object is applying an equal amount of force on the man. This thing is reaction. Action and reaction, they happen on two different objects. They never happen